In this video, we'll talk about how to solve polynomial inequalities. So we saw much earlier on that to solve a linear inequality, it's not too hard to solve it like we did with equations. Namely, here, there was only sort of one big twist here, which is, so take 1 to the other side, you get negative 2x greater than negative minus 1, so 4. And then you divide both sides by negative 2, which means you had to flip the sign. So easy peasy, right? And what would that look like, just to remind you? Well, if this is negative 2, x has to be strictly less than negative 2, so it looks like this, as far as a solution set. However, with nonlinear inequalities, it's a bit difficult. Namely, something like x squared minus 2x minus 3, we can't solve it directly, and we only know sort of how to find the zeros of it, right? Using a quadratic formula or factoring or something like that. So then the question sort of is, what do we do about it? So the big question becomes, how can we efficiently test the sign? Well, the intermediate value theorem, see video 2.2.4, tells us that a polynomial can only change its sign by passing through 0, okay? This gives us a strategy. Namely, first, we find all real zeros of the polynomial. These zeros are what we're going to call key numbers for the inequality. Then we then we go ahead and we plot the key numbers on a number line. The intervals in between the key numbers are called test intervals. Well then, since we know that those key numbers are the only place the sign could have changed, that means the sign on each individual test interval must be all positive or all negative. So we know we can only change a key number, namely we can test each interval by picking any value in the interval to test the sign. We just got to pick any value to figure out whether it's positive or negative there. So let's go ahead and work an example. Let's go ahead and solve x squared minus x minus 6 and find where that's less than 0. Then we're going to go ahead and graph the solution set. Well, here the first goal is to figure out the key numbers. Namely, we can factor this as x minus 3 and x plus 2 greater than 0. That gives key numbers of 3 and negative 2. So then we go ahead and we plot those on a number line to create the test intervals. And actually, I want to have enough room to write this, so I'm going to write it this way. Well, I have, so negative 2 would be about there, 3 would be about here. And then what I do is I draw these out. Now I'm going to write each of these factors over here. And then I sort of have, and the nice thing about this is I know that testing each of those factor signs contributes to the total sign. Okay. Well then here, I can pick any values I want because I know in this whole interval it's either positive or negative and it can't change its sign except at that key number. So, pick your favorite value, for instance negative 3. If you plug negative 3 into here, you'll get a negative value. If you plug it into here, you'll also get a negative value. Well, that negative value times that negative value will give me a positive value. If I pick 0 on this interval, I could pick 1 or negative 1 as well. It doesn't matter, because no matter what I pick, will give me a negative value here and a positive value here. Well, a negative value times a positive value gives me a negative value. Similarly, I know that picking any point in here, I can test. I'll get a positive value. I'll get a positive value. Positive and positive gives me a positive. Well then, what I have is plotting, I know that here is where the expression equals 0. Here, the expression also equals 0. Here it's positive, here it's negative, here it's positive. So now I just need to go back and figure out what satisfies this part, the less than 0. Well, less than 0 would only be this interval, so the answer is negative 2, the interval negative 2 to 3. That is, if I draw that out, it's only that part of the number line. So negative 2 to 3, open, open, because we can't have it equal to 0. If it was less than or equal to 0, I could include those points. But I know it's not, so that's my solution. So now it's time for you to try an example. Go ahead and try solving using the key numbers and the test intervals. X squared minus x minus 20 less than or equal to 0, and then graph the solution set. On the count of 3, I'll reveal the solution. 1, 2, 3. So here again, I factor. I find my key numbers. Those are the only places that the sign can change, so I mark them down to get my test intervals. I test each of the factors separately, the sign on them, combine the sign to get the total sign, and then I just read off. So again, because it's less than or equal to 0, I need to find wherever it's negative and wherever it's equal to 0. Putting all that together, I get the interval -4 to 5, closed on the endpoint. Graphed out looks like that. For more practice and sort of the basics of solving the polynomial inequalities, be sure to see page 185 and work problems 1, 2, and 5 through 12. In our next video, we'll delve a little bit deeper into solving polynomial inequalities with more examples.